Hi, my name is Josh Carlson. I'm joined here with Charles, Sam, and Nick, and today we'll be talking about pole vaulting with the use of composites. Pole vaulting is essentially an athletic event where an athlete takes a pole, runs down a track, and attempts to clear a bar with the highest height possible. The ultimate goal is the athlete who clears the highest bar wins.
Pole vaulting, as we know it, began in the late 19th century. Early poles were made of ash wood. These eventually were replaced by bamboo and briefly steel and aluminum. These early poles exhibited little bend, as seen in the figure on the left. Glass fiber composite poles were introduced in the 1950s. With some small changes in both technique and composition, athletes were able to clear much larger heights. Although all poles in the modern age of the sport are glass fiber or carbon fiber composites, there is technically no rules regarding the composition of the pole. Although unlikely to be seen in competition, a pole vault pole should be able to bend 180 degrees without failure. The goal is to clear the tallest height possible, and to do this, an athlete must choose a pole with the perfect balance of length and stiffness for their individual needs. Poles that are too stiff for their length reach peak height too early, while poles not stiff enough for their length are unable to straighten completely to reach peak height. For athletes, the most important factor of a pole is that it performs as advertised. Elite manufacturers engage in quality control stages so athletes know what to expect from their equipment.
And so the manufacturers need to focus on the properties of said materials that they use. And so there are three main things that we're going to touch on: flexural strength, bending stiffness, and the ability to absorb and then release that stored energy. So in flexural strength, the stronger the pole, the more weight is required to bend said pole. This means larger individuals or faster runners, with kinetic energy being the key operative term, can use heavier poles. A pole vaulter simply does not want an easily bendable pole, as the pole will not be able to release that energy quickly and achieve a higher jump. However, a pole vaulter does not want a brittle pole, as it can snap while vaulting. Bending stiffness. The two materials used in the pole, carbon fiber and glass fiber, give two different roles in the pole. The carbon fiber gives the pole the stiffness, or quote-unquote springiness, as mentioned by a pole vaulter we interviewed, that allows the pole to quickly release the strain energy imparted onto it by the vaulter. However, releasing the energy too quickly can be problematic, and thus the glass fiber comes into play. The glass fiber allows for a much more even and controlled release of the strain energy, which gives the vaulter more time to achieve proper form while still allowing the pole to both absorb and release energy. This property given by the glass fiber is seen as more important than that given by the carbon fiber. The ability to absorb and then release energy factors in these 2 points. It is apparent that a balance must be found between stiffness and flexibility. Both materials must be able to absorb the kinetic energy of the runner and then release that energy safely and without failure. The reinforcing nature of carbon fiber allows for a quicker release of this energy, but the glass fiber allows for a more even and controlled release.
Production of a pole starts with filament winding of a fiberglass epoxy pre-preg in the hoop direction on a steel mandrel. The mandrel has a soft side where the steel bends under its own weight, so the alignment must be marked. All future wraps will start here. Different patterns of fiberglass or carbon fiber pre-preg are added in either with a bidirectional weave or a longitudinal weave. Stiffeners are added next, and this is usually a rectangular piece of fiberglass or carbon fiber to add extra stiffness. After that, a spiral or straight wrap is added, and these are tailored to the desired bend and stiffness and strength characteristics of the final product. So a straight wrap will probably be more towards a stiffer pole, and then a spiral wrap will be towards a stronger and less stiff pole. And the angle is dependent entirely on desired properties. Then a sail wrap is added, and this provides additional properties at critical points, such as extra strength at the bend point. Then the pole and the mandrel go into an oven, and this can either be steam or oil heated for about 45 minutes at 175 to 300 degrees Celsius. Once it's removed from the oven, then the mandrel will be removed, and the pole will undergo quality testing, such as in the picture here seen with the flex test. And then the flex test will determine the flex number and the weight limit. Then finishing processes will be performed, such as sanding, paint, vinyl, logos, grip, etc.
In conclusion, pole vaulting has been transformed over the decades of composite poles. Athletes in search of a unique trade-off between flexibility and strength found their solution in the form of composite poles. This trade-off between stiffness has been achieved through the use of both glass and carbon fibers to create highly controlled properties in these poles. Athletes are now flying higher than ever with composites, and they will continue to do so for the foreseeable future.